Do you want to make your own automatic door opening system? Well, if your answer is yes, then watch this video from start to the very end, because at the end of this video you will be able to make your own automatic door opening system. Before we start working on this project, first watch a preview of what we are going to make. I'll be back. Hi guys, my name is Fahad and welcome to Electronic Clinic. If this is your first time here and you want to learn Arduino programming, PLC ladder logic programming, SCADA application designing, SolidWorks, Visual Basic application designing and programming, for microcontrollers to send and receive data, Android, security systems, robotics, image processing and much more, start now by subscribing and clicking the bell icon so that you never miss anything. Welcome back, and let's start building the automatic door lock opening system. The components we will be needing for this project are This is the circuit diagram of the automatic door lock opening system. The schematic is prepared in CADSoft Eagle 6.3.0 version. You can easily download this software from the internet simply by searching through Google. As you can see in the circuit diagram, the infrared sensor is connected with Arduino. Its 5V is connected with Arduino 5V, and the output of the infrared sensor is connected with pin 4 of the Arduino, and similarly the ground of the infrared sensor is connected with the ground of the Arduino. And over here the electronic lock will be controlled with the help of the relay driver circuit. Over here we have a relay which is of the type ESP32. It's a 12V relay, and we will use this relay to control the electronic lock. So the electron lock that we will be using has two wires. The one is the 12V wire and the other one is the ground. So one side of the electronic lock will be connected with plus 12V and the other side will be connected with the normally open pin of the relay, and the common will be connected with the ground. So the 12V is connected directly to the electronic lock, and the ground to the electronic lock will be controlled with the help of this relay, and this relay will be controlled with the help of this 2x222 NPN transistor. So as you can see, for the relay we need 12V, so one side of the relay is connected with 12V, and the other pin of the relay coil is connected to the collector of the 2x222 transistor, and the emitter is connected with the ground. So the ground will be connected with this pin through this NPN transistor. So when we turn on the transistor, the emitter will short with the collector, so the ground will short with this pin, and the relay will turn on. So when the relay turns on, this pin will short with the normally open, and a path will be completed and the electronic lock will turn on. So this relay will be connected to pin 13 of the Arduino. So this is the complete circuit diagram, and over here instead of the battery we can use a 12V adapter or a battery. So that's it. This is the complete circuit diagram, and now we will start building the circuit, and then we will do the interfacing, and then after that programming, and then finally the checking. This is ESP32 single pole double throw 12V relay, and this is the only information I have for now, and I don't know anything else except its schematic symbol, which is just in front of me. The coil pins: common, normally closed, normally open, but I have no idea which one is the common pin. I don't know which one is the common pin, which one is normally closed, normally open, and which one are the coil pins. This is all the information I have, and using this information I have to design the driver circuit. So let's start with finding its pins, and let's use a digital multimeter. Now Here's a digital multimeter, and you can see I've already set this continuity, and I can check the continuity. Okay, now this is, so now first I have to find the normally close, normally open, and common pins. So let me select any pin you want to start with. For example, I'm just touching it over here. Let's check this one. No, it's not, yeah, it's beeping. So now there is a beep sound, so it means one of these two pins is common and one is normally closed. But which one is which? Now we have to find this one. But let's make a box and write the information. So now we have these two pins which are connected, and now the remaining three pins, this one, and this one. So maybe these two are the coils or these two are the coils. So now we have to find the two coil pins and the one normally open. So let's start. So as you can see on the DMM, it's given as 0.394K, 0.394K. So R is equal to 394K. Let's check once again, and yes, 0.394K. Okay, and we know that this is a 12-volt relay, and formula we will be using is V is equal to IR, and I is equal to V by R. So 12 volt divided by 0.394K. Let's use a calculator, and 12 divided by 0.394, which is equal to I is equal to 30 milliamps. So this is the amount of current we will be needing for energizing the relay. Now from this value we can find out the transistor. So any transistor whose collector current is greater than this value can be used to control this relay. So in my case, I will go for a transistor whose part number is 2N2222. So this is the NPN transistor, a general purpose NPN transistor, and this transistor is easily available in any electronic shop. So now let's make the circuit diagram. So this is the these two are the coil pins, and this one is the common, and this is normally closed, and this is normally open. So as we will be controlling this relay with the help of microcontroller, so let's add a transistor. $10K, and this side will be connected with plus 12 volt, and this is 2N222. This transistor will be used in saturation mode. This is the collector, this is the emitter, and base. So any NPN transistor, for example, if 2N22222 transistor is not available, then you can use any other general purpose NPN transistor whose collector current is greater than the 30 milliamps. So just go for that, and we can add a diode over here for the back EMF protection. So this can be 1N4007. Now we will start Now we will make the simulation and write an Arduino program to check whether this circuit is working or not. So let's open the Proteus and start designing. So while the Proteus is open, click on the Pick from Libraries button and write Arduino Uno. So just we will need this one and a resistor. We will also need a relay. Click OK. Right click and rotate. So now these are the pins. These are the two coil pins 1 and 2, and this is the common pin, and this is the normally close and normally open, and it's a 12 volt relay. Okay, now we will also need 2N222 transistors, so 2N222, which is an NPN transistor. Double click and add, and let's trigger it a little bit. And we also need a resistor. We will connect this to pin 13 of the Arduino. Connect this one. It's where here. Now we will need some power terminals, so click on the terminals mode button and select here power. Double click and write plus 12 volts. Now select ground. Okay, now let's also add a lamp, so click on the component mode, click on the button which is the pick from libraries and write lamp animated light bulb, so add also this one. And let's keep this side. Ground and power plus 12 volts. Okay, now let's start the programming. Let's save this first. Chip tutorials, relay driver, and this is the simulation. Now let's open the Arduino Uno and write programming. So integer relay equal to 13 and void setup and void loop. So pin mode relay is output. Let's keep the relay off by default, so digital write relay low, and let's write a very basic program in which we will turn on and turn off the relay after each and every second. So digital relay high delay 1000 milliseconds, which is equal to 1 second. Digital write relay is low and delay 1000. And let's compile this. Now as you can see, we have a hex file, so copy this link, press Ctrl C on the keyboard, double click and paste this over here and click OK. Now let's play this. as you can see. So the circuit that we have designed is working just fine. This is 2N222 transistor. This is a relay, 10K resistors. We have added 10K resistor because it's a BJT, a bipolar junction transistor, and it's a current control device, so that's why we're just adding this 10K for the current limiting. So this is the electronic lock that I will be using today. And well, actually I don't need this, so I will cut this and connect a DC socket so that I can easily power this up using a 12-volt adapter. So I'll cut this, solder these wires, and for this I will be needing a cutter and a wire stripper. And the wire stripper is optional if you can remove the insulation with the help of the cutter. So once I am done with the soldering for this, then I will be back and then we will start soldering for the relay driver circuit. So now let's connect the DC socket. Okay, now our DC socket is connected, and now let's check this. Okay, this is 12 volts and it's working just fine. Now let's start the relay driver circuit. It's a Vera board and it is an ESP32 relay. Now let's solder this. This is an NPN transistor, and the leftmost pin is the emitter, the middle one is the base, and the rightmost is the collector. And this is a 10K resistor, and I'm connecting this with the base. Okay, now the next step is now I will connect the collector of the 2N222 transistor with the coil pin of the relay, and the emitter I will connect with the ground. So once I do these connections, then I will be back and explain this. So okay, now all the wires are connected. This is a 10K resistor which is connected with the base of 2N222 transistor, and this is the emitter, and this one is the collector. So as you can see, the collector is connected with one side of the relay coil. Okay, and the other side is connected with the positive, and the ground wire is connected with the emitter, and there is another wire which will be connected with the Arduino ground, and this wire is coming from here and which will be connected to pin 13 of the Arduino. Through this wire we will turn on and turn off this relay. And there are two more wires, this one and this red wire, the blue and the red wires. So blue wire is connected with the common of the relay, and this one is connected with the normally open of the relay. So we will connect, so these are the two wires to which the electronic lock will be connected. So now I will do the interfacing. So all the components are now connected. So this is the relay driver circuit which I explained in detail. So this is connected with pin number 13 of the Arduino. This is the white wire, and you can see from this side, here it is connected with pin number 13, and the ground of this circuit is connected with the ground of the Arduino. And this is the electronic lock, and as you can see, the two wires of the electronic lock. So I cutted one wire and then I connected it with the normally open and common pin of the relay. So this is connected in series with the relay, and this is the 12 volt to the electronic lock. So this 12 volt will be given to the electronic lock through this relay. And this is the infrared sensor. So its ground pin is the gray one, is a ground, and it is connected with the ground pin of the Arduino. And this another one is the 5 volt, which is connected with the 5 volt, and the white wire is connected with pin number 4 of the Arduino. So this is the program. Let's start with the integer relay is equal to 13. It means that relay is connected with pin number 13, and integer sensor equals 4, and this is the infrared sensor is connected with pin number 4. You can use any other pin if you want. And white setup, pin mode relay output. As we know that relay in this project, the relay is used as an output device which will be controlling the electronic lock, so that's why it's output, and by default we keep it low. Pin mode sensor, sensor is an input device, so that's why it's input, and digital write sensor high. Now white loop executes infinite time, while the white setup executes only one time when we turn on the microcontroller. So if digital read sensor equals to low. Okay, now the type of sensor, the infrared sensor I'm using, it will give you output when it senses something, like it will give you low at the output when it senses something, and when there's nothing in front of the sensor, it will give you a high signal. So that's why I'm using low over here. So if digital read sensor equals low, it means that check if there is anything in front of the sensor, then digital write relay high, then turn on the relay. When you turn on the relay, the electronic lock will open, and it will remain open for 5000 milliseconds, and which is equal to 5 seconds. So if the digital read sensor equals high, it means if there is nothing in front of the sensor, then then turn off the relay, so the electronic lock will turn off. Like normally using delays in a program, like it's not a good practice, but as in this project we are not using other sensors, so it doesn't matter if I use a delay or not, because I'm not monitoring other sensors, or I'm not taking data from other sensors. So for this project it's just fine. But if you have sensors in your project, then I suggest that you use the millis function to create your own delays, so that it doesn't affect the other sensors. So that's a very simple program. Let's compile this, check for the errors. I have already checked this and it's just working fine, and I've already uploaded this into microcontroller. So right now there is a program and it's working just fine. I have added a 5 seconds delay, so the door opens for 5 seconds and then it automatically closes. So it's purely automatic. When it's sensing anything like an obstacle, it will turn on. So again, so it also makes this as a touchless control system. So if you liked my video, subscribe to my channel, like and share my videos with your friends, and if you have suggestion, please leave a comment, and thanks for watching.